Hi everybody, this is our lesson for today. We are doing lesson 27-3, Identifying Functions, and that is on page 366 in your book. So please pause the video, get out your book, open it to page 366. Excuse me, let's get started. So here is our definition. We talked about this last lesson, but they're actually defining the set of all the input values as the domain and the set of all the output values as the range. We already knew this, and that's how we're creating our two bubbles that we're using for mapping. So here they gave us some points in example A, and then they pulled out all the x values and made that the domain, and they pulled out all the y values and they made that the range. So for try these A, they want the domain and the range of each relation. So I might say domain, I'm going to make a D for that. And then I'm going to use my curly brackets because it's a set. But I'm only going to pick the x values. So if I look at the x values for these points, they are all the same number. So I am only going to have 1, 2 inside my set. The domain for this relation is 2. You're not going to write 1, 2, 3, 4, 5 2s, just the 1. For the range, I'm going to use an R in curly brackets. And if I look at the y value, 4, 5, 6, 7, 8, I'm going to fill those numbers in. 4, 5, 6, 7, oh, I'm off. 6, 7, 8. And then end my curly brackets. So that's the domain and the range for A. For B, again, I'm going to use D for domain, and I'm going to use my curly brackets, and in the domain I've got a 3, a 4, a 12, and a 1. I could put those in order. 1, 3, 4, and 12. That would be my domain. And then for the range, I'm just looking at the y values. So I've got 8, 12, 12, and 12. So just 8 and 12 are the elements in the set. Oh, that's poorly done. In the set that is our range, set of all the output values. Go ahead and give problem number 1 a try. So pause the video. Problem number 1 is asking about these two that we just did. All right, welcome back. Hopefully, to make a map, you made an oval of the domain. So this is A. So that's 2. And an oval for the range. So 4, 5, 6, 7, and 8. And then an input of 2 leads to an output of 4, input of 2 to 5, input of 2 to 6, input of 2 to 7, input of 2 to 8. So no, that is not a function. This one input has way too many outputs. It's only allowed to have 1. So for B, I'm going to write down my elements first and then put them in an oval. Sorry, every time. I can't help it. All right, and then my range is 8 and 12, so I'll put those in an oval. And then if I look at this table, I know an input of 3 leads to an output of 12, an input of 4 leads to an output of 12, an input of 12 leads to an output of 12, and an input of 1 leads to an output of 8. So that's my map. And yes, this is a function. Because if I ignore the range, I can see in my domain that I only have one line coming off of each number. Each one of these inputs only leads to one output, and therefore it is a function. All right, if we turn the page to page 367, we have a check your understanding. Determine the domain and the range in each relation, and then state whether the relation is or is not a function. So go ahead and pause the video and give these 3 problems a try, please. Okay, so for problem number 2, the domain for this, I'm looking at the x values for each coordinate pair, and they're all 3. So the domain is 3. The range, for the range, I'm going to look at the y values, and I've got 9, 10, 11, and 12, if I put them in order from smallest to largest. Whoops, I'm sorry, I got them mixed up. That's a different problem. All right, so the range is 5, 6, 7, 8, and 9. 5, 6, 7, 8, and 9. And if you mapped these, that was great. But hopefully you can see that no, this is not a function because an input of 3 has more than one output. Problem number 3, the domain. So now we're not looking at coordinates, we're looking at a table, and that's kind of easier because my domain are all of the numbers in that first column. So the domain is 1, 2, 3, and 12, and the range is 9, 10, 11, and 12. And yes, this is a function. And without mapping it, I can tell it's a function because each of one of my input values is only in the table once. So there's no way for one input to have more than one output because it's never written twice. All right, number 4 might be the trickiest one for you. How'd you do? So for the domain, for each one of these points, I'm just going to look at its x value. So I'm going to go straight down. So for this point, the input is 1. For this point, the input is 2. And then I have 3. And then 4. And 5, 6, 7, 8, and 9. And 10. I got 10 here too. So 4, 5, 6, 7, 8, 9, and 10. So those are all the x values for each one of these points in the graph. For the range, now I'm going to look at the y values for each point. So for this first point, the y value is 1,000. For the second point, the y value is 2,000. For the third point, the y value is 3,000. And we keep on going. 4,000, 5,000, 6,000, 7,000, 8,000, 9,000, 10,000. So 4,000, 5,000, 6,000, 7,000, 8,000, 9,000, and 10,000. That is the domain. Is this a function? Yes, it is. Each one of these inputs on the x-axis is leading to only one point, which gives me one output. We'll talk about that some more next lesson. This was a super fun activity that we had to be in class to do, so we will just skip right through that. We'll skip right through this. Please join me on page 369. Page 369. Take a look at Check Your Understanding. The table shows the results of a survey of 5 students about the number of siblings they have and the number of pets they have. Use the table to answer question 14 and 15. So 14 says, use mapping to determine the relation that associates the number of siblings to the number of pets as a function. Is it a function? Explain your reasoning. So go ahead and pause the video. Give 14 and 15 a try. Okay. Welcome back. Problem number 14, if I use mapping, it says, it's hard to know what my input and my output is here, isn't it? It's not like the number of siblings leads to a number of pets, or if you have more pets, you're going to have more siblings. So I think we just have to choose. In general, if I look down here, when they write a sideways table, they almost always put the X on the top and the Y on the bottom. So that's what I'm going to do up here. I'm going to say number of siblings is my input, my X value, and the number of pets is the output or the Y value. So they want mapping, so I'm going to write my domain, the set of all my inputs, 0, 1, 2, 3, and 4. And then I'm going to write the range, the set of all my outputs. So that's the Y value. So I've got 0, 1, 2, and 3. All right, and then I'm going to connect them. So an input of 1 leads to an output of 2. So 1 goes to 2. An input of 0 leads to an output of 0. No siblings, no pets. That's a lonely child right there. Input of 2, output of 1. Input of 4, output of 1. Input of 3, output of 3. All right, so is it a function? You should have said yes. And to explain yourself, you should have said each input has only one output. I'm not sure if that will always be true, but for this survey, it is true. Number 15 says, use mapping to determine if the relation that associates the number of pets to the number of siblings is a function. Oh, I thought that we did 14. Oh, I see. So this is siblings to pets, and this is pets to siblings. So we're going to switch the x and the y. So what if we switch the domain and the range? I'm going to do that up here. So here's the range, 0, 1, 2, 3. But now I'm going to say that is the input. So my input is the number of pets. And then I'm going to make the domain the output. So the output is the number of siblings. So 0, 1, 2, 3, 4. And now when I'm looking at my chart, I'm going to say the input is 2. When the input is 2, the output is 1. When the input is 0, the output is 0. When the input is 1, the output is 2. When the input of 1, the output of 4. When an input of 3, output of 3. So if I look at it this way, starting with pets and then comparing it to siblings, is it still a function? The answer is no. And the reason is an input of 1 has 2 outputs. It goes to 2 and it goes to 4. And those 2 outputs is what stops this relation from being a function. All right, I'm going to skip the practice and let you do your homework instead. So thank you for joining me today and have a lovely afternoon.